But today we're going to talk about microscopy and how to use a microscope. Next week we'll talk about staining in lab. So I'm going to go through this, like I would normally discuss it in class. And then we'll watch a video that actually does a pretty good job of talking about almost everything that I would do when I was showing, when I would show you an actual microscope. At least you guys have taken 150, so you have a little bit of experience using a microscope. But in microbiology, we use a microscope a lot, so you would have gotten a whole lot more experience. So we're going to go over to all the parts of a microscope, which you're already familiar with those, but also their functions. We'll show how to correctly use, care, and clean the microscope. We're not going to prepare any slides because obviously we're not meeting face-to-face, but we'll talk about these kinds of things. And I already mentioned Antony von Leeuwenhoek, and so here he's mentioned again. Remember, he created superior lenses because he developed his own technique for grinding them. It's basically just a magnifying glass, but it could magnify up to 500 times, so it was really, really excellent. But the microscopes that we use are light microscopes or bright field microscopes, so they use white light as our source of energy. And we know the light source or the illuminators on the bottom, and the light goes up to the condenser, which helps to gather that light, to concentrate that light, to send it straight up through the slide and through the specimen. We talked about the objective lenses, where the light comes through so you can actually see the specimen. And we're going to go over the concepts of field of view, right? Because you're familiar with field of view, right? The whole circular area that you see. And who can tell me what happens to the field of view as you increase magnification? It gets smaller, right? So as you increase magnification, the diameter of the field of view gets smaller. So what that means is whenever you find the specimen or find the object on the slide, you need to move it so it's directly in the center of the field of view. So each time you change magnification, there's still something there in the center. If there's not anything in the direct center, when you change lenses, it may now be outside the field of view, and that just makes it harder to then try and find it again. So whenever you initially find something, move it directly to the center of the field of view so that there will always be something there. Now when it comes to depth of field, this applies to organisms that are big and thick. So we would have given you some slides to play with, just to look at some prepared slides, like paramecia, amoeba, blood, some miscellaneous stained bacteria. And for the paramecia and amoeba, and especially the amoeba, remember those are much larger organisms. They're eukaryotes, they're protozoans. And so on the low magnifications, you would see the entire amoeba. By the time you got to the high dry or the oil lens, you would not be able to see the whole thing anymore. In fact, what you could see was just one small part that was clear. All the rest of it would be kind of fuzzy. And the reason why is that the organism is thick. So you can't focus on the whole thing all at once and have it all in focus. If you remember back to 150, when you looked at the colored thread slide, remember we had 3 colored threads, and you had to figure out the order of the threads, which one was on top of the other. And so you played with the depth of field. You played with the focus knobs, right, to focus one colored thread at a time. And that way you could determine the order. So if you're looking at a very thick organism, just keep in mind that the higher the magnification, you zoom in real close, but you only see one small part in great detail. All the rest of the organism is blurry. Resolution we talked about, right? The ability to distinguish two things as separate. We talk about refraction of light, the bending, which is why we need to use immersion oil on the highest magnification lens. So let's review our magnifications, starting with the lowest power lens, the scanning lens. what would be the total magnification of the scanning lens? Ocular times the scanning lens? 40. And the low power lens would be how much total? 100. The high dry lens? 400. And the oil lens? 1000. Now, you've heard me say the high dry lens multiple times. Why do I call the 40x lens the dry lens? Why is 40x the high dry lens?
Because it's the highest magnification without needing oil.
Right, and in fact, you should never use oil on the dry lens. But having said that, it's likely the student before you may not have cleaned their microscope that well. So whenever you get your microscope, the first thing you do is clean it, starting with the ocular lenses, then the scanning lens, and work your way up to the oil lens. But you really need to make sure that the high dry lens is clean, because even the slightest smudge of oil will make it almost impossible to see through it on high dry. So high dry should never have oil. You always have to clean it thoroughly. And even as you're using it, and we'll talk about this in a minute, you may accidentally get oil on the high dry lens. You always want to clean your lenses. Now, when it comes to working distance, that's something important because the shortest lens, the smallest lens, is the scanning lens. And when you're focused on a specimen using the scanning lens, it's at least 1 centimeter away from the slide. So you got a lot of working distance. As you increase magnification, those lenses get longer. And so the distance between the lens and the slide gets smaller and smaller. When you get up to the high dry and the oil lens, that lens is almost right on top of that slide. You have about maybe 1 millimeter of distance right between the lens and the slide. So that increases the risk that you're going to break the slide if you're not paying attention to what you're doing. So when it comes to focusing, we have 2 focus knobs, right? The larger inner knob, the coarse focus, and the outer knob that sticks out, the fine focus. So you use the coarse focus when you're on the low magnifications because the coarse focus moves the stage a lot. You use the fine focus when you get up to high dry and oil because the fine focus just moves the stage a little bit. If you're on high dry or oil and you grab the coarse focus, you only have about 1 millimeter of working distance. So you turn that too far and you're going to break the slide. And if you were very unlucky, you would break the lens, which is very expensive to replace. So as you change the lenses, the distance between the lens and the slide gets smaller and smaller. And that's why I use the coarse focus on low magnification and the fine focus on high magnification. That way you won't break the slide. So we see the ocular lenses. Remember, they magnify 10 times. We have the objective lenses, 4, 10x, 40, and 100x. You put your slide on the stage in between the clips. And on our microscopes, it's not shown here, but we'll see it in the video. There are 2 knobs here attached to the stage that allows you to move the slide back and forth from left to right, also forward and back. So you can move the specimen around. So we see the light source and the condenser lens underneath the stage. And there's also a light intensity control, the rheostat, which you normally should turn all the way up, maximum brightness. And then students complain, oh, it's too bright. So what is the other way to reduce the amount of light coming through the lens? If I'm telling you to turn the rheostat up to maximum, what is the other way to reduce the amount of light? You also have this thing. It's part of you. What opening, Christina? Right, the iris diaphragm, right? So the iris diaphragm, which is not shown in this image, but it's attached to the condenser, and we'll see it in the video. So the iris diaphragm is the other way to adjust the amount of light coming up to the specimen. So when do you close the iris? When do you open the iris? So when do you open, when do you close the iris?
Is it true you open it when you want less light and you close it when you want it to be brighter?
The opposite. So close it to make it darker, open it to make it brighter. But when do you want to do that? Using what magnifications? No idea. So remember the openings on the bottom of the lenses. On the scanning lens, the lowest power, the 4X, big, huge opening. As you increase the magnification, the opening gets smaller and smaller and smaller. So when would you want to open the iris? When would you want to close it? Well, what about the oil lens, Christina? Which one? Well, you want to open it on the higher magnifications and close it all the way on the lower magnifications, right? Because the openings on the bottom of the lenses on low power are so much, bigger that too much light comes through. So you always close the iris to start. Once you get up to high dry, you can open the iris a little bit. You don't necessarily need to open it all the way, but you would learn how to play with the iris. So one of the things about the microscope is you always have to make adjustments each and every time. And one of the things that students don't like to do is you see here there are two oculars on the microscope. How many eyes do you have? Yeah, two. So what does that mean? Yeah, right. You're supposed to use both eyes, right, to look through the microscope. And there are ways to adjust it, so that it can fit your eyes, whatever the distance is between your eyes, or if your eyes are not equal, you can make adjustments so that it works for your eyes perfectly. So, so when you carry a microscope, you're supposed to use two hands because these things are heavy. So no one-handed, carrying the microscopes, unless you happen to have $2,000 to spare to replace it when you break it. Always clean your lenses before you get started. That's very important because the student in the class before you may have been in a hurry to get out and may not have done a good job cleaning. So you always clean your lenses before you start, and always clean your lenses before you finish, or when you finish. So make sure they're clean. Always reset to the lowest power lens for the next student to get started. Now, when you put on a slide, and you'll see something in the video, and I'll stop it just to mention that I disagree with it. And the reason why is because we've had some mechanical difficulties with our microscopes, and what the woman shows you doing could actually end up damaging your slide or lens, but I'll get to that when I talk about it. But normally, you would lower the stage, put the slide on, move it around so the light is coming up directly to the center of the specimen, and then you slowly increase, or you slowly move the stage up as you're looking. As you keep moving and moving and moving, eventually something will come into focus. So once you're in focus, you then move to the next lens. You should be very nearly in focus, so you shouldn't have to make but minor adjustments usually. And so then you move to the high dry lens. When you're on the high dry, now you use the fine focus only. And when it comes to the fine focus, because it's fine, you only should ever turn the knob a few turns in one direction or the other, because you should be very nearly there. You should be close. So you don't have to turn the fine focus knob that much. And you should never, under any circumstances, sit there and crank and crank and crank the fine focus. That's not how that works. If you were in focus on the lens before, you should only need to make a fine adjustment to bring it into focus on the high dry and then next on the oil. So fine focus, you shouldn't have to turn that knob very much at all. So let's say that you're focused on the high dry. Remember, you have to open up the iris to let more light in. Then you're ready to add the oil. So the way to do that is you simply move the high dry lens out of the way. You put the drop on the slide in between the high dry and the oil lenses, and then you slide the oil lens into the oil. Now, students are always worried, oh, but what if the oil lens, touches the slide? Well, the oil lens is supposed to touch the oil. That's the purpose. If the oil lens actually hits the slide, you can't actually move the oil lens in place, then that means you were not in focus on high dry. So you have to go down to a lower power. And if you were focused on high dry, but when you go to oil, you lose it, you also have to go back to a lower power. And here's where students get oil all over the high dry lens. So if you need to go back to a lower power, you have to pay attention to how you rotate the objectives. You do not want to rotate the high dry lens through the oil, which is what frequently happens. So you got to make sure to go the opposite direction so that you don't get any oil on the high dry lens. But you go back to a lower power lens, you should go back to the 10x lens. And the reason why you go back to 10x is because you can easily focus through the oil. That's not a problem. And from the 10x, you can jump back to the oil lens. So you can go from 10x to oil. That works just fine. Right? Because remember, now you got oil on the slide, you can't go back to high dry because there's oil on the slide. So, but you can go from 10x to oil, and that works just fine. And then you find your specimen. Now, if the oil lens still keeps hitting the slide, the most common explanation for that is because your slide is upside down and the specimen is pointing towards the ground. And that does happen frequently, especially with students making their own smears. A really thin smear, it may be hard to see on which side it is. And so students accidentally flip the slide over when they put it on the scope, and you can focus on bacteria which are on the bottom of the slide all the way up through high dry, but when you try to go to oil, you can't get close enough to focus because the specimen's upside down, the slide's upside down. So that does happen. But ideally, you go step by step, lens by lens, making minor adjustments, keeping everything in focus, and then you go to oil. Everything should be good. If you lose it when you go to oil, carefully rotate the objectives so you don't get oil on the high dry lens, back to 10x, focus through 10x, and then jump back to the oil lens, and things should be good. Now, when you're finished looking at that slide, there is something that students always do, mostly because they're taught to do this, and I don't know why, because it makes no sense to me. But when you're finished with that slide, tell me, how do you remove that slide and prepare for the next slide? What would you do? Step by step, tell me, what would you do? Right, to remove the slide that you just finished looking at, and you want to look at a different slide, how would you remove the first slide? And don't be shy. It's okay to be wrong, because most of you probably will be wrong. So how do you go about removing that first slide, right, to prepare for the next slide? What do most students do? We could loosen the clips. Yes. Right, so there we have what students most commonly do, which is lower the stage to take the slide off. I don't know why you're told to do that, because here's the thing. So you just put this slide on, right? You found it, you focused, you went all the way up to oil, everything's good. So when you take that slide off, if you do not move the stage, the next slide you put on, you're there. You just need to make minor adjustments. So why would you want to lower the stage and start all over again? I mean, you're wasting time and effort by having to go back and do everything all over again. So what I tell students is just move the oil lens out of the way, making sure not to get oil on the high dry lens, but move the oil lens out of the way and simply take the slide off the stage. When you put the next slide on, start on low power and you should be able to see something, right? Because you were focused on the previous slide, so you're there. It just makes things a lot faster and more efficient if you do not lower the stage. But for some reason, that's always taught to students, and I don't know why. If you want to lower the stage and start all over again, you can do that, but you're making it harder on yourself. All right, so again, when you're finished using the scope, you clean off all the lenses, wrap the cord around it, and put it back where you got it from. So now there are no observations, because what we would normally do is just have you look at some of these slides, like the prepared slide of blood or paramecia, miscellaneous bacteria, and have you draw it, for example, under low power and then under high power or under oil, so you can see the difference and the reason why we need to use oil most of the time. But we're not going to do that. So we have a few questions for you to think about and then answer. So, think about it. If you think you know the answer, then let us know. What is the function of the condenser lens again? And you can take a minute to think about it. Well, the function of the condenser lens. So, well, focuses the light, right? That's part of what it does. So it does help to gather all the light coming from the light source down below. So it does help to gather that light and direct it straight up through the slide. What's the function of the iris diaphragm? What's the function of the iris? Right, to open to let more light in and close to less let light, right? So you're controlling the light, because as I said, you should turn the rheostat all the way up to maximum brightness and then use the iris. When do you open the iris and when do you close it? Under what magnifications? or just in general, right? Low power, we close the iris. On the higher powers, we open it, right? So coarse and fine focus. What magnifications or what powers do you use the coarse focus, and then when do you use the fine focus?
The coarse focus is for the lower magnifications and the fine focus is for the higher ones.
Right, so on the 4x and 10x lenses, use the coarse focus. When you get to the 40x and 100x, use the fine focus. And that way you most likely will not break a slide. Because someone always breaks a slide, always happens. So what's the maximum magnification for our microscopes? Ordinary light microscopes, maximum? (1,000 times, right? So yes, that is better than Leeuwenhoek's microscope, but remember Leeuwenhoek made his a couple hundred years ago, or a few hundred years ago, and so his could magnify up to 500 times, so his were excellent. Ours are better, but you know, considering what he did back then, I mean, he was pretty amazing. So when you go to the 100x lens, if you had to put the oil on, what would you expect to see? Would you be able to focus the specimen? What would it look like? So you're saying, Taylor, you would not be able to see anything? Right, you would see something, it would not be crystal clear and it would be darker. So you can see the specimen using the 100x lens, but it's not going to be bright, it's not going to be clear. So that's why we need to use the oil. I mean, the difference, you know, when a student goes to the oil lens and forgets to put the oil on, they're like, I'm having trouble seeing this. When they put the oil on, it's like night and day. It's such a difference. And of course, you did not observe any specimens today, so there is no best specimen to be observed. But any questions on the microscopy handouts?
Is this handout in Blackboard also?
Oh yeah, that's what, yeah, it's there.
Okay.
So I'm going to stop recording and stop sharing this and then try to share my screen and see if that works.